In this lesson, we're going to be using exponent properties to simplify expressions. Before we begin, let's do a quick review of each of the properties that we've gone over so we can use them in our examples. The first one we went over was product of powers. So product of powers let us take two algebraic expressions if they had the same bases and they were being multiplied together. We could then keep the same base and add our exponents together. Now our quotient of properties was very similar, quotient of powers was very similar because we were taking two algebraic expressions, they were divided together and had the same base. We could then take their exponents and subtract them. Now power of a power just had one exponent that was raised to another exponent. So if I had a to the m and it was again raised to the n, I then took my exponents and I multiply them together. Now power of a product is one of the ones that we just went over, where instead of looking for the common base, we're looking for the common exponent. So let's say that I have an a and a b, so my bases are different, but I'm going to raise it to the same exponent. Now since this is a product, I have to be multiplying them together. And I'm going to then be able to just multiply my bases together and raise that to the common exponent. Similarly, power of a quotient has if you have two bases are different, but your exponents are the same, and you're dividing, then we are going to divide our exponents. Our bases. We're going to divide our bases and raise it to a common exponent. So let's try a few examples now that we've done that quick review. So your directions will probably tell you to simplify each expression and write your answer in exponential notation. So our first example is going to be 4 to the 5th times 4 to the 3rd over 2 to the 2nd times 2 to the 6th. So the first thing that I notice is that I have two bases that are the same. Now when my bases are the same, I know that I can use my product of powers property, which allows me to keep the same base and add my exponents together. I can use the same property again because again I have these same bases. I have these common bases, so I'm going to keep my base and I'm going to add my exponents. So let's simplify this expression. So I have 4 and 5 plus 3 gives me 8. So I have 4 raised to the 8th in my numerator. And then in my denominator I have 2 raised to the 2 plus 6, which is also 8. So now I see something else that reminds me of my properties. I see these same exponents. So this allows me to use my power of quotient property, which tells me that I can take my bases and divide them, and I can keep them raised to the common exponent. So 4 divided by 2 gives me 2 to the 8th. Let's try one more example. So let's say we have 5 to the 5th times 2 to the 9th times 5 to the 4th over 10 to the 3rd. The first thing I notice are these two common bases I have. So I'm going to be able to use my product of powers property to simplify this. So I'm going to take my common base, which is 5, and I'm going to add my two exponents together, which is 5 plus 4. Now I still have 2 to the 9th. I have not done anything with that. And I will still have 10 to the 3rd. We can simplify this. So 5 raised to the 5 plus 4 gives me 9 times 2 to the 9th times 10 to the 3rd. So I see that I have these common exponents. So when I see those exponents that are the same, I'm going to use my power of a product because I'm multiplying. So I'll use my power of a product. So I can simplify my numerator to 5 times 2 raised to the 9th over 10 to the 3rd. So 5 times 2 is 10, so my numerator becomes 10 to the 3rd, or the 9th, divided by 10 to the 3rd. And I see these common bases again, so I'm going to be able to use the quotient of powers property. So this tells me that if I have these common bases that are being divided, that I'm going to subtract my exponents. So I have 10 raised to the 9 minus 3, which gives me 10 to the 6th when I simplify it. And that's how I kind of combined all of these different properties to simplify expressions.